Hi viewers, and we're completing our full video tutorial with the Python to drive this assembly. Now if you've been following along, we're creating a square washer, a bolt and a spring. So the spring is animated via an adaptive pipe, and this will be the Python that controls this. So we started animating in our previous video, and I'm going to actually show you how to create this Python with this little GUI with a start stop that controls the animation loop. And the Python itself is not too bad. So we've got our window, our button click that starts and stops the timer, and the code that drives the animation by changing the height of the helix. Remembering that the height of the helix also determines the pitch as well, because we've got a little equation in there on the helix. So I jump back in here and look at our spring, drop this down and we'll see our helix. Then we can see the equation here, and we've got this divided by 4 on the height. So we've kept that one in there because that won't cause any DAG errors at all, and we're just driving this height via the animation. And we'll look at that next. If you like this video, please hit a like and also subscribe to the channel. I also have a Ko-Fi site where you can actually donate to my contributions to the community, and that's at ko-fi.com/mang0. Okay, let's start by creating a macro. So I'll go up to macro and macros, and I'm going to create a new macro in here, and I'm going to call this Spring Assembly Macro. And this is going to be animating our assembly. Now we're going to start off by creating first the pop-up window that's going to control the assembly. So I'm going to do it from a window rather than from the Python command line. So we'll be able to stop and start our timer from this window. So we're going to go through it from scratch here. It doesn't take long. So the first thing I'm going to do is import some libraries. So I've got the text nice and big for you so you can see what I'm doing. So I'm going to import the pyside.qt-GUI first, and I'm just going to import everything. So from pyside qt-GUI import star, that's importing everything, and I'm going to create a class to hold this. So what I'm doing is creating a class, and I'm just going to call it some arbitrary values. So I'm going to call it my window. So this is going to be the window, and in the brackets I'm going to put QWidget. So I'm extending the QWidget of the Qt GUI. So basically this will take on all of the properties and methods of the QWidget. Now for our class to start up, I'm going to give it a init, which will run each time this class is actually created. We don't have to run this ourselves, we just, when we create the class, this will actually get initialized. And in that I'm going to call super, which calls the QWidget. So that pulls in all the methods and properties. So we first pulled in QWidget, and now we're running the init method on the actual QWidget itself. So the same as what we're doing here, we're actually running an init, and I'm going to pass in my window. So this is the name of the class, and we use self in there as well, so we always reference into self, and then I do dot underscore and run the init method of the QWidget. So this goes back to QWidget and runs the init method on there. We need some flags for our window. So now we've taken on all the methods and properties of the QWidget, we get access to things like set layout and window flags and set window flags, etc. So I want to set a window flag on there, and what this will do, the flag that I set will stop it from being minimized into the background. And the reason why I'm setting this flag is in the Qt namespace, so Qt dot, is to make it stay on top. So window stays on top hint, and that means when we swap from this macro, when we hit play on this macro and swap to the scene, our window will stay on top of that. We can give it a title if we so desire, but I'm not bothering. So I'm just going to go self.show, which will actually show the window. And of course, I have to set up a little variable that instantiates this class. So my win equals my window, and that will just run this. So my window equals my window means it will come up here, it will create a class called my window, pull in a Q widget. Now this init is run each time because it's the default constructor, and self is this class. We can call self, or basically this variable, we can call it any name, but self is the user way. We then run the super, which runs the Q widget init, which brings in all the methods and properties of that. Then we use this, because we got all the methods and properties in, we get access to set window flag, and we're setting a window flag on there called window stays on top hint that makes sure it stays on top of everything, so when we swap tabs we won't lose it in the background. And then we do a self.show. So we run this now, our window has appeared, and we can swap back and forth. So that's our window done. Now we're going to add some buttons in there. So I'm going to come in here, and it doesn't really matter where we add this. What it does, because we're placing it in a layout, so self-show should be the last thing we do. And in here I'm going to do self.button start stop, so this will be our start stop button to run the animation. You can call this whatever you want, and I'm going to equal that to a QT push button or a Q push button, and in brackets you put the animation button's name, and I'm going to call it start stop because I'm going to be using the same button to start and stop the animation. To add the button to the actual window itself, we need to create a layout. So I'm going to call variable layout, and we've got a number of layouts in there, and I'm going to use a QH box layout, horizontal box layout, and that will create a layout for us. We've got to add things to this layout, so layout.add widget will allow me to add the button. So in brackets I can put the self.button start stop in there. So that's added to the layout. Then we've got to add the layout to our screen. So self.setLayout, and then we pass in the layout. So we've created a button, self.button start stop. We've assigned it to a push button with a bit of text there. We create a layout, horizontal box layout, which then is filled with our widgets, and in this case we're just adding one widget in there, which is our button start stop. We then add the layout to the screen, so self.setLayout, in brackets our layout. So what we should get is, you notice our window is now being constrained to that button. So that's the layout that we've added in there, and it's got a start stop in there. This is the reason why we do the self.show last, because if that was before our layout, so if I do it before the add in the layout, then our screen will be larger, because adding the layout will shrink your screen to the layout that's been added. So we'll always do the self.show last. So that's good. So we've got that in there, but our button doesn't really do anything yet. So we're going to put some basic code in here. I want the button to run a function. So I'm going to call the function define the function as button click, and again we place self in here, and when this button clicks, all I'm going to do is app.console, so I'm outputting to the console .print message, and I'm just going to print a simple message in there of clicked. So we should see that in our report view. Well, we've got the button click, it won't work just yet, so we need to add this to the button. So we need to connect it up. Now the button has a number of events on there. So self.button start stop, and we can get to the events, and one of them is the clicked event. So that's just clicked. And we need to connect something to that clicked event. So connect, and in brackets we actually pass in the self dot button click, which is our method. So this one down here, we don't need to put a bracket and self in there, because if we did that we would actually be running the method. We just need to reference the method in there. So that's added the click event in there, and it's assigned this method to the click event. So we run that now and also see our report view. View panels report view, so we can see what's going on. We just clear this out. Now when I run this and hit start stop, you can see the clicked has come up. So that's basically everything we need with our GUI. Now what I want to do is each time we hit the start stop button, I want to keep a variable updated with the state of what we're in. So it will check the state whether we started the animation or stopped the animation, and then flip-flop between that state. For that we need a variable, and I'm going to put the variable in here, and I'm going to call the variable self.hasStarted. We initialize that with the false. So we'll initialize it with something called a boolean, so we set that to false, so false and true. Next we come down here and we're going to do a little conditional statement, a little if statement in here, and we're going to say if self.hasStarted. So if it has started, now I'm not going to bother with the brackets around that because I don't need it. So self has started, and we're going to use the same console message, and I'm just going to push that forward so it's inside the if. I'm going to put the text stopping animation. Also need to set the self.hasStarted to false. And then after that we need to do an else. Now this else means that it hasn't started, so if it has started then do this, else do the next one. And I'm going to use the same console print in there, but have it as starting animation instead of stopping animation. And of course we need to flip the self.hasStarted to true. And what we should get is when we click the button now, we should get a stopping, starting, stopping, starting message come up. And I'm going to come in here and just place a new line character on the end of here, so we see them underneath each other. Let's clear this, give this a go. I've got invalid syntax there, that's because I've missed the colon on the end of the else, so miss that. Let's just clear that off. So our window has appeared. So that's there, so hit start an animation. Now if you look here, we've got a problem here. We've got equals false. Now in most languages false is lowercase, which always gets me, so let's start that again. So that's actually working now, so you can see starting, stopping, starting, stopping. Clear that out. So that's working nicely. That always catches me out, that one. So we've got a nice flip-flopping between the start and the stop animations there. We can now integrate our timer, because this will allow us to start the timer and stop the timer rather than the normal way of opening up the Python console and typing timer.stop after you've pasted this code in. We don't need to do that anymore once we've got GUI in front of us. So let's create the timer. So we need a import for the timer. So from PySide.Qt core this time, and inside the Qt core there's a Q timer, and we need that. We need to import that, and I'm going to create the timer down here, so it doesn't matter where we place it. I'm just going to place it towards the top. So self.timer equals Q timer. Open and close those brackets. And what we need also is a method that's going to run. So I'm going to come down here, and I'm just going to tab over, and I'm going to call the method update, and also pass self in there. And I'm going to place in here another app.consolePrints message, and I'm just going to put the word update in there so we know that's been triggered by the timer. So we've got our timer in, we've got our function or our method that's run each time the timer's run. We now need to connect that to that method. So self.timer, and we need to hit the event called timeout. So each time that timer times out, so each loop of that timer, we actually set a time for this, a millisecond time that we can place in there to do this. And we need to connect, and in brackets we place update in there. So we're calling the method update. Matter of fact, it's self.update, and that pulls in that method and connects it up to the timeout event of that timer. Now for the timeout event to work, we need to actually set the milliseconds of the timer. And we do that when we actually start the timer. Now I'm going to create a variable up here, and I'm going to set that to a millisecond. So self.millisecond, and I'm going to have something like 10 milliseconds in there. So what that allows me to do is change this, and this will change the timer once it's all connected up. So that's all the timer parts there. We will now start the timer. So we come down here, and where it's got starting animation, we need to start the timer. And this is where the milliseconds come in. So we come down here, and self.timer.start will start the timer, and then we pass the milliseconds. So self.millisecond. I believe it was millisecond, not milliseconds. Yeah, milliseconds. So that'll start the timer. We also need to stop the timer, otherwise it's going to go on forever. Come up in here, self.timer.stop. Open and close the bracket. So now we're starting and stopping the timer, and what should happen is our update should fire each time we time out after 10 milliseconds. So let's just check through. So we've imported the timer from the Qt core. We've created the timer and assigned it to our class. We've created milliseconds as well. Now we've connected our update method to the update function here, and it just outputs update. And then when we go into our button click, we can see we have the timer here. We stopped it if it has already started, and if it hasn't already started, we've started it. So let's clear the screen. Now I've noticed I've missed out the colon there again. Def updated, make sure that's there. Give that a go. So that's started the application. Hit start, and we can see the update is running there. Hit stop, and the animation stopped. The animation timer stopped, and that's exactly what we want. So now we've got a basic animation timer there, and I'm going to save that off. And this code, we can use it for any animation that we want. So this is our basic blueprint for starting a animation with a start and stop. There is a video on my channel for this process, and that can be found on my channel to actually get just the animation loop. But that's all we need to start and stop our animation. So what we'll do now is get into creating that animation and driving those pieces. For that, we need to access the parts in our assembly. So we've got our assembly here. I'm just going to full screen this to give us a bit more to work with. So here's our assembly, and I want to drive the spring. So whenever our spring is increased, so if I go down to my spring, which is here, the spring part and the helix, whenever the height of that helix is increased, and the screen is refreshed, we can see that drives the animation. So to do that, we need to get to the helix. Now if I go into my Python view, so view panels Python, I always changed the helix, so there will be a command in here where I've actually changed the helix. There's that refresh command. So just before that, we've probably got freecad.getDocument spring getObject helix.height equals the 80 millimeters. I'm going to change that slightly, but that's the command that I want to use. So I'm just going to copy that, jump back into the macro, and in the update I'm going to get rid of this console print message because we don't need that anymore. And this is where I'm going to be driving the animation from. So what I'm going to do is assign up that helix in my class. So I'm going to make a variable in here called self.helix. I'm going to equal that to freecad.getDocument spring.getObject helix, and I don't want the height in there because I'm going to be setting that. I just want to pull in the object. So anything that I do to self.helix now will be done to freecad.getDocument spring. In other words, the actual part in the assembly. Get document is the document name, so if this differs, look down here, spring, if this differs you'll have to change that to yourself, but if you change in the height in your helix, you automatically get this command in your Python console that you can use. Or you can use the freecad.getActiveDocument and then use that to actually get the active document that you're using. So we've got that in there. I'm going to set some barriers now. I'm going to set the max and min height that I want the helix to expand to and compress to. So for expansion, self dot, I just can call it max actually, this one. And I'm going to equal that to 80, so that's the maximum expansion of the spring. And the minimum self.min, I'm just going to set that one to 40. 40 is really spring at rest, so I'm going to go 20 on that one actually. So that's the maximum that the spring can expand to, and the maximum basically what it can contract to. So maximum length and minimum length. So if it's less than 20, we know we've got to start expanding the spring. If it's greater than 80, then we know we've got to start contracting the spring. So if we come down into our updates, we can put those in. So in here, I'm just going to keep it easy for starters. I'm just going to output some messages onto the screen. So I'm going to first check to see if our helix, so self.helix .height, and then we use the dot value in there because before height was, you can see, just come out of 80 millimeters, but if we use dot value, we actually get the value of the spring, the height value, in as a float. I'm going to say if it's greater than equals to our self.max, so greater than equal to 80, then I'm just going to use the app.console print message in there and say it's at maximum expansion. I'm just going to say at max there because when we're starting coming into contraction and expansion, then maximum contraction is actually the minimum length, and that starts to get things complicated in our heads, and we need to keep this simple. So self.helix.height.value greater than equals self.max, then we just output a message. We're going to do the same for the min as well. So we're going to say if self.helix.height.value smaller than or equals to self.min, so it's contracting. I'm going to again use the app.console print message, and I'm going to say at min as well. Otherwise it won't print any messages, and then we know we're in the middle part where we're expanding or contracting. Let's clear this. And hit start. At the moment it's at max, and that's because our helix height is 80. So this is continuously working its way down. So if we do the height to 10, it's now saying at min. So 80 at max, 10 at min, so that's 100, 10 at min, so that's working quite nicely. 20 is right on our border. Obviously this won't show a message for the middle part, but you'll see this is moving up, so we put this at 30, it should stop outputting messages. So now it stopped outputting messages, and we can move down and start outputting messages at min now. So there we go, so that's working, it's working quite nicely. And now we can stop that, so stopping animation, and the changes we make won't take effect at all now. So if we set that 5, then that's all good. 85, all good. Now we've got the helix checks in here, we have to start animating the helix. So let's just close that down. Now we do that by changing the height of the helix. So depending on whether it's above the max or below the min, then we've got to actually flip-flop between the speeds, either a minus speed or a plus speed. And that will be added to our height. So if we're moving forward, we're adding a +1 or a +5 or a +10. Then if we're moving backwards, we add a -10 or a -5. So we're increasing and decreasing the spring height. For that, I need to set a speed, because I may want to change the speed of my animation to make it faster or slower by adding more rather than just adding 1 to the height. I might want to add 5 to the height or 10 to the height, and that'll make it run quicker. So for that we'll need a speed. I'm going to call this animation, no, I'm just going to call it speed actually, and I'm going to set that to 2 for the time being. Now this is going to be our original speed, so I need to keep a reference of our original speed because this is going to go from 2 to -2 and be added to the spring when it moves. Now that will be my reference speed. I also need to set the step, which is going to be what I'm going to be removing from the height, and I'm going to set that to the initial speed, and you'll see why in a minute. The step is the speed at the moment. Now come down here, and this is where we start moving the spring. And you'll see how the step and the speed come in together here. So if our height is greater than the max, then we've got the at console print message at max. So I want to reverse this. So I want to start going backwards. And what I need to do is set the step to a minus value, so we're actually moving backwards. So self.step equals minus self.speed. And what that's done is, currently our step is at 2. We'll be incrementing in steps 2 each time, 2, 4, 6, 8, all the way up to 80 or above 80, and then when we get actually above 80 or equals to 80, we reverse the step by setting it to the minus self.speed. Remember, these two are the same when we very first start out. So now it's -2, and when we add that to the height of the spring, it starts moving backwards. So that's that one done. And what I'm going to do is come in here, and we've got at max in there, and instead of at max, I'm going to put in here self.step. So we'll see what actually happens here. And I don't need that inside that loop anymore. Let's take that out. And I'm just going to place it here. So we'll see what that is each time. And same in here, self.step. Now we just want to make that, because it's going downwards towards 0, we need to make that a positive value. So self.step equals self.speed. So we're resetting a minus value. So this will be, like at this point, it will be -2, and it will be set back to 2. So we can see this working with our output. I may have to cast this as a string in a moment, but we'll see. Let's clear this out. Start running it. Hit start. You see it's -2. And now when we change this, the reason why it's -2 is because it's at 85. So if I set that to 5, it now sets itself to 2. So obviously 10, it will still be running at 2. When we get to 80, and it goes down to -2. So this is added to the spring height to make it move up and down. So that's working now. So you can see how that's working, because when that value is added to our spring height, then you're adding a minus value, so you're moving it backwards. So in here, the last thing to do really is add this to the spring height. So we do that by self dot helix dot height dot value, and we use the plus equals self dot step, and we need a refresh in here. So if we go back to the Spring assembly and just move the height a minute and go up to edit and refresh, Control R, at.active.recompute. You can see the height's 8 there, so it's actually crushed it right down. And we'll take this command here, just copy that and place that as the last thing we do in that update. So now let's close this down, save this off, go back to our Spring assembly, and we may need to set this Spring assembly at a value. So our initial value, no matter of fact, because it's crushed right down, it will get reset because it will start moving up. Let's have a look. So that's there. Go to our macros, hit the play button. We've got this, it's not playing yet. Jump over to the Spring, hit start stop, and this should go up and then come back down. So at the moment it's going quite slowly because we've got it set to 2, and also our animation frame is set to 10, so we can bring those back down. So what we should see is extends to the max, and now it's going back to the min. Let's speed it up. So start stop and close that down. I need to hit the close, so it might be a good idea to put a destructor on there that actually when it destructs, it actually stops the animation. Let's have a look, see what we got. So we've got these. Now come up to the top. Now I'm going to set the speed to a bit more faster, and I think I can come down in the milliseconds for the animation loop as well. I'll say 5. Run that. Jump over to the Spring assembly, hit start stop, and that should move a lot faster now. There it goes. So that's expanding, and what will happen, it will come back and contract. Just close these down because we don't need them anymore, and that should move back and forth like so. So that's a simple animation loop for this. So with this, you've got no problems of, remember in the previous video where we went off and changed the helix and put a reference in here to the variable, then we're not actually using that variable anymore. So we won't get any problems with the DAG errors or anything like that, and we now have got a permanently saved animation, so we can build on this animation if we so desire. So I'm going to stop that, and I'm going to go and get in and get rid of the variable because we don't need that anymore. So that was in our model and variables. So this is Spring height there. Come into here, drop this down and go delete variable, and we can choose this variable and delete that out. So we don't need that anymore. So that's our variable's gone, and all's working well. So that's how to make this animation permanent with code. The most time consuming bit was getting the window up and ready and working. So we're using animation loop in there. You could also use just a basic animation loop and paste that into your Python console, but it's pretty inflexible, and with this one you can start and stop this whenever you want, and also build upon your animation. So I hope that helped, and that is the end of the Spring animation tutorials that are on there. Check back again because I'll be doing some more around Assembly 4 later on, the usual modelling and Python scripting throughout the weeks. Thanks a lot, and I'll catch you again. If you like what you're seeing, please subscribe to my site, and also I have a Ko-Fi site. You can actually donate a few pence or a few pounds, dollars, or whatever your currency is, and that's at ko-fi.com/mang0, and there you'll be able to help me fund my site, and all the money that I actually get from any funds will actually get pushed back into the channel. Thanks a lot for watching and subscribing. I'll see you next time.